So, the problem I chose has 4 parts. The first part is finding a gradient, and then taking that gradient to compute a directional derivative in the direction of u, then evaluate the gradient at point P, and finally computing the directional derivative at point P in the direction of u. Looking at the problem, there is your important information is your value of f of x, your vector of u, and point P. So starting, we will find the gradient of f of x. In order to make the calculation a little simpler, I'm going to distribute the negative sign first. So f of xy equals negative 2x squared minus 3xy minus y squared. In order to calculate a gradient, we need to get the partial derivative of f of xy. So we need the derivatives in respect to x and y. So f in respect to x of xy would equal negative 4x minus 3y. And the partial in respect to y of f of xy would equal negative 3x minus 2y. So we take these two values and we can find our gradient. If you remember, the gradient of a function is equal to the partial derivative in respects to x, I, plus the partial in respects to y, j. So we take these and we plug them into this equation and we will have our gradient. So our gradient of f of x, y is equal to, make sure we use parentheses, negative 4x minus 3y I plus negative 3x minus 2y j. So that is our gradient that we'll be using in this function. Next, we are going to compute the directional derivative in the direction of u, which is negative 3 over 5, 4 over 5. So, in order to calculate a directional derivative using a gradient, we will use the dot product. So, direction of u of f of x, y is equal to negative 4x minus 3y multiplied by negative 3 over 5 plus negative 3x minus 2y multiplied by 4 over 5. So we distribute it and we add. So negative 3 times negative 4 will give us a 12 over 5x. Then negative 3 times negative 3 will give us a positive 9 over 5y. Then we're going to multiply the 4 by negative 3. That will give us a negative 12 over 5x. And then 4 times negative 2 will give us a negative 8 over 5y. So looking here, we can distribute some things out. You see we have a negative 12 over 5 and a positive 12 over 5x. Those would cancel out. And this will leave us with a 9 over 5y minus 8 over 5y, which, simple mathematics, will give us 1 over 5y. So our directional derivative in the direction of u of f of x, y equals 1 over 5y. Next part is just kind of plugging and chugging. So we're evaluating the gradient at point P, which is 1, 2. So if you remember our gradient here, we're going to plug in the values 1, 2 into it, and it will give us the gradient at point P. So I'll just write it here, I guess. So make sure you use the proper symbols there. And that would equal negative 4 times 1 minus 3 times 2i plus negative 3 times 1 minus 2 times 2j. Distribute it, and we would get negative 4 minus 6, or just negative 10i. And then we have negative 3 minus 4, otherwise known as negative 7j. So our gradient at point P equals negative 10i minus 7j. Oh, got kind of cut off there. All right. And our last part of the problem is computing the directional derivative at point P in the direction of u. So remember, our directional derivative is 1 over 5y. We're just going to plug the value of y into this, and we will get the directional derivative at point P. So we'll go directional derivative of 1, 2 equals 1 over 5. 2 will go for y, so it'd be 2. And that equals 2 over 5. So these are the answers to the problem.